Suppose a certain variety of Fuji apples have weights that are approximately normally distributed. They have a mean of 9 ounces and a standard deviation of 1.5 ounces. Okay, so that's all right. I have all these different apples. The mean is 9 ounces. The standard deviation of 1.5. If bags of apples are randomly filled by selecting 12 apples, what's the probability that the sum of the 12 apples is less than 100 ounces? That's our question. Right?
Yeah.
Okay. So, let's think about this. Let's let X be the weight of our 12 apples in the bag. So all the apples in that bag together, yeah? So we have some randomly selected apples. We got 12 in a bag, yeah?
Yep.
Okay, so what does that mean? So we could talk about like X sub 1. That's the weight of the first apple. Right? X2 could be the weight of the second, and so on. Okay? So that means that X is going to be X1 plus X2 plus X3 all the way up to X12. Do you agree with me?
Yep.
Does it bother you that I used an X and then there's other X's?
It did a little bit at first.
Should we change
I
it?
would have done
It bothers
X sub T
Mr.
or
Greenleaf
something.
extremely much.
Okay, Mr. Greenleaf's not in here. I'm asking if
I
it
would have
bothers
done
you.
like X sub T, like X sub the total.
So should we just call it T is total?
Sure.
Okay. Aoife, do you have a pencil that you can erase?
I'm just gonna leave it.
Okay, that's fine.
No, you have the whiteouts right there.
I'm not weighing out all of that.
No, you just changed the.
So we'll say T is the total weight. So T is going to be all those guys, right?
You just changed T.
Okay. So my average, so like I could pick 12 apples and I put them in a bag. I could pick 12 other apples, I put them in a bag. I could pick 12 other apples, I put them in their own bag. Okay? So if I do that a whole bunch of times, what's the average bag gonna weigh? Well, what would I do?
9 times.
So I could do the average for X1 plus the average for X2 all the way up to the average for X12. Which, as Kat pointed out, is 9 plus 9 plus 9 plus 9. How many 9s are there going to be? 12 nines. So 108. So on average, if I do this a whole bunch of times, okay, I have a whole bunch of bags. I randomly select 12 apples. I put them in a bag. I randomly select 12 others. I put them in this bag. I randomly select 12 more. I put them in that bag. If I weighed all those bags, on average, the bag would weigh 108 ounces, right? It's got 12 apples in it. On average, the apples weigh 9 ounces each. Yes?
Yes.
So does that make sense? So with one of these questions, if you're not 100% sure if you're adding the distributions or not, think about it, do something, and then be like, well, does that make sense? Okay, I have 12 apples in there. On an average, an apple is 9 ounces. Yeah, okay, I buy it that my bag on average is going to be 108 ounces. Okay? So we just basically took a whole bunch of distributions that are all similar to each other, and we added them together. Right? Yes? Okay, so that part's not that hard. What about the standard deviation?
Would you also multiply that by? No, you wouldn't.
I don't know.
Wait,
What do I do when we do standard deviation?
The variance plus the variance.
Square.
So
Square
square
root.
as square root. So I'm gonna take the standard deviation of that first apple squared plus the standard deviation for the second apple squared all the way to the 12th apple squared. So that's gonna be what? What's the standard deviation?
1.5.
So 1.5 squared plus 1.5 squared plus 1.5 squared.
So it's 9 times 1.5 squared. Square root.
12 times
1.5.
So 12 times 1.5 squared? Like that?
Yeah.
Okay. So you stick that into your calculator and your standard deviation is
5.20.
5.2 ounces. Okay. So if you're doing this and you're not really sure like when you should be multiplying the 12, like if you did the 12 and then you multiplied it by 1.5 and then you squared it and then you took the square root, doesn't that seem like you
Didn't.
yeah, what was the point, right? So again, like if you were like, oh, 12 times 1.5, right? And then I'm gonna square that. And now, hey, I'm gonna take the square root of that. Well, that was dumb. Like I just undid what I did. If that ever happens, then you know you didn't do the right thing. Okay? So if that happens, you know, like that's weird because that shouldn't have happened. Okay? So that's that. So now, what was the question?
Probability that the sum of the 12 apples is less than 100 ounces.
So the probability that our total weight of our apples in our bag is less than 100. Now what are we going to do? Can we do normal CDF?
Yeah, it's a normally distributed.
Normally distributed, right? And they're all normally distributed. So if we're like adding them all together, we're still going to end up with a normal distribution, right?
Yeah.
Okay, so for T, the mu of T is 108, right? And our standard deviation is 5.02. And I want to know what's the probability that it's less than 100. So there's 100, right? It'd be like that.
Do you put in 0 for lower because you can't have anything?
You could, but we probably still would do negative E99.
Even though you can't.
Even though you can't have negative apples. But if you, like, in reality, if you put 0, it would probably be fine. Honestly, if you wrote 0, it probably would be fine. Okay, I don't think you would get points taken off for that. So, the probability that T is less than 100, right? We would find that with normal CDF. Lower is negative 10 to the 9 negative blah blah blah. Upper is 100. Mu is 108. Standard deviation is 5.02. Oh my gosh, class is over.
Is it 6?
I'm gonna put 0. Let's see what happens. 100? 108? 5.02?
I think it's 5.2.
5.2? Oh.
Yeah, it is 5.2.
Okay, thank you. Okay, 5.2?
Yeah.
Yeah, you're right, sorry. So, 0.06.
I got the same.
2-ish?
It's the same. Yeah.
Okay. Okay, so about 6% of the time, if you randomly fill up these bags with 12 apples, about 6% of the time you're going to end up with a bag that has less than 100 ounces of apples in it. So, if that happened, you kind of got gypped a little bit in your apple bag. Okay? All right, sweet. We're done with 6.2.
We have a quiz on 6.1, 6.2.
No. So I will put some 6.2 homework on